Hi class, let's take a look at this problem right here. We have a difference of proportions test. Study was conducted to determine the proportion of people who dream in black and white instead of color. Among 307 people over the age of 55, 62 dream in black and white, and among 292 people under the age of 25, 17 dream in black and white. Use 0.05 significance to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion of those under 25. So this is a one-tailed test. The alternative is going to be P1 is greater than P2, and the null is going to be that P1 is equal to P2. So now we need to find all of the necessary ingredients. So let's go to StatCrunch and go to Stat Proportion Stat to Sample with Summary. Okay? And we know that the first group, we had 62 people who dream in black and white out of a total of 307. And in the second group, we had 17 out of 292. Okay? And we want to change this to greater than, okay, because this is a one-tailed test. And now we're ready to go. So let's move this down here and hit compute. The z-stat to 2 decimal places is 5.20. The p-value is super small, 0.000 to 3 decimal places. And what's the conclusion? Well, in this case here, the p-value is much smaller than alpha. Therefore, the p-value is less than alpha, much smaller than alpha. So we're going to reject the null. There is sufficient evidence to support the claim. So now what they want us to do is they want us to construct a confidence interval, a 90% confidence interval. But there's a twist to this problem, okay? And the twist is this. When I did the hypothesis test, it was a one-tailed test. By definition, confidence intervals are two-tailed tests. So that means I have to have 0.05 in each tail. So now let's go back to this, close this out, and go to Stat, T-Stat, to Sample with Summary. And again, let's enter our information. 62. Actually, wait a minute. I'm in the wrong field. Proportion stat to sample with summary. Excuse me. And let's enter our data again. 62, 307, 17, 292. And now we want a 90% CI. Okay, it has to be 90, okay, because it has to be 0.05 per tail. So hit compute, and the lower limit is going to be 0.998, so that's going to be 0.1 if I round to 3 decimal places. And the upper limit is going to be 188, 0.188. So now, what is the conclusion based on the confidence interval? Well, notice that this confidence interval goes from 0.1 to 0.188. It does not include 0. So because the confidence limits do not include 0, it appears that the two proportions are not equal. Because the confidence interval limits include only positive values, it appears the proportion of people over 55 who dream in black and white is greater than the proportion of those under 25. Thank you. Oh, wait, I got one more part. Excuse me. One more part to do here. An explanation for the results of those over 55. An explanation for the results is that those over age 55 grew up exposed to media that was displayed in black and white. Can these results be used to verify this explanation? Well, no, not really. Okay. You know, the results, okay, speak to a possible, okay, explanation. But we cannot say that this is conclusively the reason why. So even though there was statistically a difference here, okay, we can conjecture that people over 55 just were not around color TV sets, and therefore that's why they dream in black and white. But that would just be a supposition. That would not be anything based in fact. Thank you.